Okay, 162. Guys, what page? 262. Volume of prisms and cylinders. So while you're opening, while you're getting ready, this is what I'm trying to tell you. So those lame like bridal shower games or baby shower games where they have the jar and it's full of stuff. The volume, do you agree if it's full of like jelly beans, you don't want to find the volume of it? It's full of the top of it jelly beans. So the formula that I'm going to teach you today, this is what my mom does. And then she wins these every single time. Every single time. But it's fantastic because I remember in high school, they had something, some huge, gigantic jar full of something that was fantastic. Can you tell it's been a long time since high school? I just remember, man, if I would have won that. It was like full of pennies or something. But it was huge. It was like taller than me. This big, huge cylinder full of pennies was actually a lot of money. So you had to guess how many pennies were in there? Math. Use math. Okay. Let's go through volume of prisms first. Alright. What you need to get down, guys. Volume of a solid, it's always the number of cubic units inside it. So I found a picture of it. Pretty much you learn, I think, like 5th grade, 6th grade, you learn how to do volume. When you're taught songs, they teach you length times width times height. So you just times the 3 things. 4 times 3 times 2. Well, what are you doing? What is that visually? It's literally filling this prism full of cubes and then counting how many cubes are in there. How many of you, yeah, I get that. How many of you, yeah, I've seen that before. Does that make sense? This is literally what volume is.
And then how do you know how many cubes are in each of the other ones?
Oh, you're just thinking it as units of 1. 1 by 1 cubes. Great question. Good enough? These ones, super friendly. Length times width times height. However, I'm going to teach you a save all formula that goes for any shape that we're talking about today. It's this. What do you think a capital B stands for? Okay, capital B, this is tricky. Any guesses? Yeah, put them together. It's area of the base. Yeah? And then H, what's H always? Height. So since it's a capital B, it means the area of the base. Technically, if you're doing length times width times height, you're doing that. Because the base is this, right? How do you find the area of this? Yeah, so that's 4 times 3, that's your capital B. That's the base area. And then times it by the height, what's the height? So you are doing capital BH. Maybe you just didn't realize it. Part. Oh yeah, all these postulates. Get it down and then let's break it down and make sure you understand. Oh yeah, let's go over this. The very first one, it's saying volume of a cube. It's just this formula, capital B equals S cubed. What do you think the S stands for? It's just side, because all the sides are the same in a cube. Does that make sense? You're still doing length times width times height. Okay, this one, I hope this makes sense. If 2 polyhedra are exactly the same, they'll have the same volume. Nod your head. That makes sense logically, right? It would have to, right? Okay, this one, let's draw ourselves a picture. Draw a cube first. So right next to postulate 29, draw a cube. So I'm going to put rectangle in front. I guess mine will be a prism, not so much a cube. Connect, 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 connect. It's saying, what if you have like a wonky shape? So I'm going to change up the colors. And what if I had like a pyramid on top? So I'm just going to put a point and then make it up to that point from every corner. Hey, not too bad. Babcock would be proud. So it's saying if you have to find the volume of this, why don't you just find the volume of the cube and then add it to the volume of the pyramid? Does that make sense? Break it up into pieces. Stuff that you know. Find the volume of each. The volume addition postulate. You can just add parts together. This one we just barely talked about. Capital B equals capital BH. However, what does the capital B stand for? Base area. Underline it. B is the area of the base. Not just the base by itself. It's the area of the base. Volume of a cylinder. It's still V equals BH, but guys, pretend to hold a cylinder. Check, check. If it's flat and it's not rolling away, what shape are on the top and the bottom? Circles. What's the area formula for a circle? Look, right there. Pi r squared. That's base area, and then times by height. So squared. Making sure both of those are on your reference sheet. You can double check it. Okay, got them. Here's the one key concept for today, next 2 days while we're talking about volume. Okay, again, pretend to hold a cylinder. really gotta hit home what the bases are. Bases has to be the exact same shape on the bottom and the top. So if you're holding it this way, it's not the same shape on bottom and top. Does that make sense? If you're holding it this way, which two shapes are on the bottom and top? Circles. So that means circle is your base. Okay, let's switch. Just hold a box. This one's a little bit trickier. If you're holding a box, no matter how you're holding it, is it going to be the same shape, top and bottom, parallel to each other? If it's just a prism and it's a regular box. I mean, if we turn it this way, is it still the exact same top and bottom, top and bottom? Okay, watch the board. Letter A. Is it going to matter how we hold that one to make sure the bottom and the top are exactly the same? This one totally matters. For example, if I flipped it and I put this on the bottom for the base, when you're looking at it, would right above it be exactly the same shape? No, so that can't be the base. So flipped it on this side, and then we're looking at it right above that, would it be the exact same shape? This is what you really gotta hit home so you know what the base is with these. You got it, guys. Which shape has to be the base on this one? The right triangles, because then it has a right triangle on the bottom, right triangle on the top. So right here, it's ordered. Okay, write down your formula. Capital V equals capital B H. Okay, our base is a triangle, so we've got to find the area of a triangle. Do we need to bother? Let me write in here. The right angle's right here. Do we need to find this hypotenuse? Do we need it for our formula? No, we don't need it. We have everything we need. So base times height would be 1 times 3. But since it's a triangle, don't forget what? Yeah, cut it in half. All right, and then what's the height of this shape? Can you see it? This is how tall it is. So 2 would be our height. Something super convenient. Guys, what happens with our divide by 2 and our times by 2? They're gone. So what's the answer to this? Okay, this is volume. Is 3 what? Yeah, feet cubed. But does anybody know why we switch? Area we do squared, feet we do cubed. Do you know why?
Because you're doing 3 dimensions.
Perfect, 3 dimensions. We're timesing 1 foot right here, times 3 foot right here, times another 2 feet right here. There's 3 feet cubed. Okay, letter B. It's that formula, right? But I like that it makes sense from this one. From this one, what shape is the circle? Oh, did you hear what I just said? What shape is the base? Circle. So let's use pi r squared. That's the area of a circle. And we can't forget to times by h. Okay, what's r in this example? Alright, so let's do pi times 5 squared. And then what's height in this example? Okay, so let's practice terms of pi and our final answers. Okay, help me out. What's 5 squared? 25 times 6, that's 6 quarters. 150 or 125? 150. So final answer, we could just put 150 pi meters cubed. Or grab your calculators, let's put both. Put the decimal answer. So again, grab your calculators, type it in. 150 times pi. That'd be somewhat big, right? Alex, do you have that? What is it? Sorry, tell me one more time. 471 meters. Oh, 0.2. I'll leave it. 471, good enough for me. How many degrees, Alex? We good? How many feeling okay about these so far? Feeling all right? Okay, let's see what's next then. Oh, guys, you got this. Will you try these on your own first, please? All right, the right prism. Such a friendly question. Technically, you are using the formula capital V equals capital BH. Guys, shout it out. What are you timesing for capital B? Totally. The base is 11 times 4. And then what's the height of this one? So times by 5. Mental math. Can I do it? 55 times 4. I don't know. 44 times. Help me out. What is it? 220? 220 what? Thanks for saying cube. Meters. Cube. Okay. Number 2. talk myself through it. It's still capital BH. But what shape is the base on this one? Circle, because then it's top and bottom, same shape. So that's pi r squared for the area times my h. All right. So that would be pi times what? 6 squared times 9. Did any of you leave it in terms of pi? Callie, what did you get in terms of pi? 324 pi feet cubed. How many agree with Callie on that one? Okay, does anybody have a decimal answer you could help me out with? Tyler, what did you get? 1017.88? Input 0.9. How many got same decimal? Feel good about that? Okay, the next two, I think they're backwards problems. Yep. Okay, I'm teaching you a new button on the calculator. How many of you are using classroom calculator? Let me see. How many of you have a calculator pretty similar to the classroom calculator? Alright, those of you who don't have a classroom calculator but something similar, you might have to do some scavenging. Okay? Just watch, we'll help you find it. So right here, this is a what? It's right here. Cube. So volume is just S cubed. But they gave us volume. Volume of this is what? So we've got 90 equals, instead of S, I'm going to put this variable right there. X cubed. You okay with that logic? Okay, well, how to get rid of a cube? Cubed root. Has anybody used the cubed root on a calculator? You have?
Yeah.
Okay.
The square root symbol with an X.
Uh-huh. Perfect. Okay. Is it dark blue colored root?
What do you mean?
Yeah.
Where is it on your calculator? I can't
It's
remember.
on the side right here. It's the one right there. The one that would be like the square root for another number that wasn't.
Okay.
I
Okay.
don't know how to explain
Look for it. So Moot described it perfectly. It's a square root sign, but you need an X in front of it.
it.
Oh, I see it. I think it's above the caret.
Yeah.
So
That's
you've got this button. Yep, that's called a caret. And then above the caret in light blue, do you see it?
Yeah.
It looks like this.
No.
Right here, right?
Yeah.
See that?
Yeah.
Do you know how to get to that though?
Yeah, you press second.
Okay. Now cleared out because that X is saying, what do you want there? Because you can do a fourth, a fifth, a sixth. What do we want there?
3.
So you gotta push 3 first. Push the 3, and then the light blue second button, and then get that.
So it'll be 3x square root.
Let me try, I gotta see what it looks like. So turn on
You'll stop at X.
3, and now the cubic root. Oh, I did the wrong one. Second. Yep, so it looks like this. You've got a big 3, and then an X, and then a square root symbol.
So couldn't you do that with any number of 10?
Yes, you can. That's why X is there. It's saying you can put whatever number you want there. All right, we want the cubic root of 90. So now type in 90 right there. Oh, I did not see that coming. So X is 4.48. Anybody nervous about that answer? Do you know how to double check it? Yeah. Or let's use the caret button. The caret button is the power button. So just keep that 4.4814. Keep that in the calculator. Hit the caret button. This is the caret button. So it takes your answer, and then put it to the power 3. Ta-da! What happens? Oh, mine was 90. It went right
How
back to
do you
90.
put it to the power carrot
I'll use the caret button. And that way it knows to times that decimal by itself 3 times. So I check my answer. How many of you used that button before? How many of you used it? How many will I get it now that I've seen it? Does it make sense to you? Okay. Let's go backwards on letter B. So letter B, they give us the volume. Okay, this one, pi r squared h, right? Base times height. So volume 1,253 equals pi times r squared times, what's height in this one? 10. Okay. What do you want to start doing to isolate the variable? Yeah, we could divide by 10. Could you do anything else? You could divide by pi. Could you divide by 10 pi? What do you think? Yes, you can. Divide by everything at once. Divide by 10 pi. Divide by 10 pi. Now you need to be careful with your calculators. Your calculator, if you just type it in like this, will do 1,253 divided by 10 and then times by pi. But we want it to divide by 10 pi, so put parentheses in there. If you don't believe me, test it out. You'll get two totally different answers. 39.9? Alright, so we have 39.9 equals r squared. Now what? Square root it. So r is going to be estimated, it's probably 6 something, right? 6.3 meters. What if it asked for diameter? What would you do? Double it. Just pay attention to your directions. Thumbs up. How are you feeling about this section? Halvesies? Down? Okay, listen closely. I'm going to give you a hint on your assignment. Hints on the assignment. Put your fingers or finger on number 6. Number 6, which shape is the base? Right. It's got to be that triangle, so you have triangle on top and bottom. Okay, think about this. If you take number 6 and you flip it onto its base, what number becomes the height?
1.
Very good, Taya. 1. Okay, number 7. Number 7, which shape is the base?
Triangle.
Triangle again, right? If you flip it onto its base, the triangle, what number becomes the height? Okay, number 8. Number 8, what shape is the base? Do you remember the area formula for a trapezoid? Okay, I'm gonna write it on the board if you don't have your reference sheet handy. So this is number 8's hint. Number 8, the base is the trapezoid. So if you're gonna use this formula successfully, you gotta know the base formula for a trapezoid, base area formula. So it's 1/2 times height times b1 plus b2. Do you remember what those stand for? Yep, base 1 plus base 2. Okay, think about number 8. If you flip number 8 onto its trapezoid bases, what number becomes the height? Write it down. There's your hint. What about number 9? Which one is the base? I would use the hexagon. Use the hexagon as the base on number 9. Okay. Good, good, good. Ugh, number 14. Flip it over. You can do it. It's like the last chapter. Okay, number 14. Which shape is the base on that one?
Those are facing us.
What shape is that though? It's a trapezoid, so I'm going to put this as a hint for number 8 and number 14. Except for number 14, don't use 3 right there. That technically is a trapezoid for the base. Do you see
The
it?
height would be the 30.
Uh-uh. I agree with McCall. Ellie said height on number 14 would be 30. No, if you flip onto its trapezoid, height's going to be 15. Question, Boo?
This actually doesn't have